Hey, welcome back. And sometimes I say welcome back because I've gone off and done a whole bunch of stuff and had an entire day. Like I went rock climbing with my kids, and now I'm back. And it's Saturday night. And this is a really busy semester because I'm working on a Saturday night. And statistics, this class is going fast. Um, it can be taught over 18 weeks or 9 weeks. And if you happen to take the class on a 9 week semester, man, this class moves. All right, so now we're gonna take a look at a couple of cool diagrams. And so here's a diagram with a box with a circle in it. And here's a diagram of a box with two circles in it, and they overlap. And here's a diagram with a box, two circles in it, and they overlap, and they're colored differently than this one. And here's a diagram with a box with two circles in it, and they don't overlap. And we're gonna learn about those and how they relate to probability. And in particular, we're going to learn about the complement of an event, a union of two events, an intersection of two events, and mutually exclusive events. And to learn about this, you have to remember these terms here. So you remember we have an experiment. An experiment is a process that generates well-defined outcomes. So we do an experiment and we get some outcome, right? And then we have a sample space, which is all of the outcomes. And so here's our sample space of tossing a coin 2 times. And then an event is a subset of a sample space. And so it's some event for which we maybe want to know the probability of something. And so, if we have some event here, and so we want to know the probability of something, we'll call that event A. Then there's a complement to event A. And it's everything that occurs which is not event A. So the complement of event A is defined to be the event consisting of all sample points that are not in A. So all sample points that are not in A. The complement of A is denoted by A with a C to it. And I think one of the cats is in this part of the house where they're not supposed to be. Hang on one second. Okay, so we just got kittens, and so we have like a kitten quarantine area. I don't know if that's the right word. We have an area where the kittens are supposed to be, and one of them just went racing by. All right, it's been captured, and we put it back where it's supposed to go. So here we have, we have a sample space, right? So this box is a sample space, and event A is a subset of the sample space, and there's some probability of event A occurring. And then the complement of event A is everything in the sample space which isn't there. So why would we want to know about this, right? For some reason, I closed my ChatGPT. Let me open it back up. So here's my ChatGPT and statistics probability. And I put a little definition in up here. First, let's just look at why we might want to know about this. So there's union, and then there's intersection, and then there's complement. So imagine you're at a party with 30 guests. Out of these, 12 guests are wearing red. You randomly select one guest to give a prize to. Question, what is the probability that the guest you select is not wearing red? So there's 30 guests, and 12 of the guests are wearing red, which means 18 of the guests are not. So the complement of, a guest wearing red, so if the sample space is all of the guests and we have the probability that 12 are wearing red, 12 out of 30, the complement of 12 out of 30 wearing red is 18 out of 30, and 18 out of 30 is 0.6%. So if we come over here and we do like 18 and we divide by 30, we get 0.6, right? Which is 60%. So 60%, right? It's 60%. And so here's how ChatGPT explains that. To solve the problem, you'll need to calculate the probability of the complement of the event, selecting a guest wearing red, right? So you'll need to calculate the probability of the complement of the event, selecting a guest wearing red. So the event, identify the event A. The event A is selecting a guest who's wearing red. The number of guests wearing red is 12. Calculate the probability of event A. Total number of guests, 30. Number of guests wearing red is 12. Probability of selecting a guest wearing red is 12 out of 30. Find the complement. The complement of event A, denoted as A dash or A with a bar over it or A with a C next to it, is the way our textbook does it, is the event that the selected guest is not wearing red. So the probability of the complement, so this is the complement, is 1, which is the total probability, minus everything that's in the event. So that would be this picture here, right? So here's they're wearing red, and the complement to that is not wearing red. Anybody not wearing red, which is out there. And so when we do 1 minus PA, we have the PA, right? The probability of that event that they're wearing red is 0.4. So 1 minus 0.4 is 0.6. So the probability that the guess you select is not wearing red is 0.6 or 60%. The problem illustrates how to calculate the complement of an event and understand the probability of the opposite outcome occurring. So, if you know some statistics, like we knew they were wearing, 12 of the guests were wearing red, and we wanted to know the probability that the guest you select is not wearing red, the event A is that they are wearing red, and then the complement of A is that they're not wearing red. But, it's just kind of like thinking it through. It's kind of a logical thing. I don't know, when I just read this part here, I could kind of do all that sort of in my head, what needs to happen. And then here's the solution for that. So that is doing the complement of an event, and that's this picture here. And again, the complement of event A is defined to be the event consisting of all sample points that are not in A in that sample space. The complement of A is denoted by AC here according to the textbook, but according to ChatGPT, it's denoted by an A with a little dash after it. So the complement of event A is shaded here. All right, that's the complement of an event.